Probability distribution is one of the most important topics in engineering mathematics. Now what this topic contains, what kind of questions might be expected, what is the basic concept is what we'll be seeing today. Now when I say probability distribution, what usually comes to mind is what kind of distribution. I'll give an example. Suppose if I say a student wants to answer 4 multiple choice questions. He wants to answer 4 multiple choice questions. Now, when I say multiple choice questions, let us say there are 4 options available. So, the student wants to appear or wants to attempt 4 different questions, and every question has 4 options. Now, I am going to assume that the student is not aware of the answers. He does not know what the answer to that particular question is. That means he is going to answer all the questions by sheerly guessing. That means if he is going to attempt a particular question, let us say, as I said, there are 4 multiple choice questions. Every question has 4 options. That means when the student is going to attempt by sheer guessing, the probability, the chances of his getting a correct answer becomes 1 by 4. So I can say probability of getting a right answer. Getting a right answer will become 1 by 4, as 4 options are available. So out of 4 options, I can select one option. So it can be done in 4C 1 ways, that is by 4 ways. And there is only one correct option. So the correct option can be selected in 1C 1 way. That means the probability of selecting a correct answer would become 1C1 upon 4C1. That means 1 by 4. So probability of selecting a correct answer is 1 by 4. Likewise, there are 3 wrong options. That is why probability of getting a wrong answer becomes 3 by 4. Now people always remember, while learning probability distribution, there are 3 different types of distribution that you want to understand. Our today's lecture will be entirely focused on the first type of distribution. Now, the 3 different types of distributions are, first one is called as binomial distribution. Binomial distribution. So our today's lecture is entirely based on binomial distribution. The second one is going to be Poisson's distribution. We will be covering this in the forthcoming lectures. Poisson's distribution. And the third one is a normal distribution. Third one is a normal distribution. Now, the first 2 distributions, the binomial distribution and the Poisson's distribution, are applicable only for a discrete random variable. It is applicable only for a discrete random variable. Whereas a normal distribution can be applied for a discrete as well as a continuous random variable. So I can write discrete random variable as well as a continuous random variable. So, in our today's lecture, we are entirely going to focus on the first type of distribution, that is called the binomial distribution. Now, to understand this distribution, to understand what is probability distribution, what I have done is I have taken an example. In this example, I want to answer 4 multiple choice questions. So, I am going to limit my trial. Attempting a question becomes an experiment. I am performing an experiment expecting some result. So the experiment that I am performing is called as a trial. So here my trial is, I am attempting one of the MCQs. I will attempt the MCQ one more time, then again one more time, and one more time. In such a way, I will be attempting the MCQs 4 number of times. So I am doing one particular event 4 times. So that becomes my trial. So I am doing, or I am attempting 4 MCQs. So number of trials is 4. I am going to denote number of trials by n, and and the value is 4. So same thing is done 4 number of times. You are attempting a question, again you are attempting another question, again another question. So same thing is repeated 4 number of times. So this activity that you are doing repeatedly, that activity is called as a trial, and number of trials that you are performing is denoted by n. In the example that I have taken here, n equals 4. So I am taking 4 MCQs. I am trying to solve 4 MCQs. Now, as I do not know any of the answers, I am going to answer these questions by sheer guessing. Every question has 4 different options, and out of the 4 options, only one of the option is correct. That means my probability of selecting a correct answer is 1 by 4. Then the probability of selecting a wrong answer will become 3 by 4. Let us say success is when you get a correct answer is your success. Success means whatever your desired outcome that you need to happen. Desired outcome here is getting a right answer. So getting a right answer becomes my success. That is why I can say probability of getting a right answer, which is now called as probability of success, is 1 by 4. The probability of success is denoted by small letter p. So p is probability of success. Probability of success. Likewise, the probability of failure, which is nothing but getting a wrong answer, it is 3 by 4. I am going to denote it by q. So this is called probability of failure. Now people understand, a binomial distribution can be applied only when a trial can have only 2 outcomes. Binomial distribution is also called as Bernoulli's distribution. Whenever a particular trial happens and the trial can give us only 2 outcomes, then it is called as a Bernoulli's distribution. Since there are only 2 outcomes, hence we are naming it as binomial distribution also. So we will be coming on to why this specific word has been used, binomial distribution, once we understand this one particular example. So Bernoulli's trial, why it is called Bernoulli's trial? Because the particular event that is going to happen, it can give us only 2 outcomes. So if you observe, if you are going to attempt a question, if you attempt a question, there can be only 2 possibilities, either you will be right or you will be wrong. That means this event is giving us only 2 outcomes. So whenever 2 outcomes are going to come, the problem is definitely going to fall into binomial distribution, or we also call it as Bernoulli's distribution. So let's come back to the example. So as I had 4 MCQs, I'm going to attempt these 4 MCQs. I do not know the answers. Every MCQ has 4 options. So getting a right answer, probability of getting a right answer becomes 1 by 4. Getting a right answer is my success. So I'm going to call probability of success as P. Getting a wrong answer becomes failure. So I'm going to call it as Q. So if you observe, P plus Q, if you do, it is going to come 1. So this is a very important statement, that whenever you are doing a question on Bernoulli's distribution or binomial distribution, P plus Q has to come 1. We will be proving it also a little bit ahead. So P plus Q is definitely going to become 1. So now let's understand the different possibilities in which I can answer these 4 questions. Now remember, when I am going to attempt 4 questions, try to understand, try to think on the different possibilities that you can have. So when you attempt 4 questions, is it a possibility that out of 4 questions, not even a single question came correct? That means your success of getting a right answer was 0. Out of 4 options, 4 questions that you had, you have to answer the 4 questions. But out of the 4 questions, none of the questions came correct. That means your success is 0. There is a possibility that out of 4 questions, only 1 question came correct. There might be a possibility that you have answered 2 questions correctly or 3 questions correctly, or there is a possibility that you might have answered all the 4 questions correctly, and all these things are happening by sheer guessing. That means the probability, the possibility of getting right answers is either 0 right answers, or 1 right answer, or 2 or 3 or 4 right answers. This 0, 1, 2, 3, 4 is nothing but your random variable. So I am going to write capital X. Capital X is getting right answers. Getting right answers. So therefore I can say x can be 0 questions are answered correctly, so 0 right answers. 1 question is answered correctly, or 2 questions are answered correctly, or 3 questions, or 4 questions. So x becomes your random variable. So 0 questions answered correctly, 1 question answered correctly, 2 questions, 3 questions, 4 questions. So this x sometimes also denoted by small letter x. So these values are denoted by small letters. So I can write x is equal to xi. So x1, x2, x3, x4 and so on. So these are values of capital X. These values are denoted by small x. So x is 0, 1, 2, 3 and 4. So 0 questions answered correctly, 1 question answered correctly, 2 questions, 3 questions, 4 questions. So now when x becomes equal to 0, try and understand. When x is 0, that means you have answered 0 questions correctly. 0 questions are answered correctly. So if 0 questions are answered correctly, that means when you answer the first question, it came wrong. What is the probability of getting a wrong answer? It was 3 by 4, or I can denote it by Q. The second question that you answered is also wrong. What is the probability of getting a wrong answer in the second question? Again 3 by 4. Or I can say Q. The third question also came wrong and the fourth question also came wrong. That means when I say x is equal to 0 questions are answered correctly, the first question is wrong, the second is wrong, the third is wrong and the fourth question is also wrong. That means I can say the probability of getting a wrong answer, getting all of the questions as wrong answers. So P of x equal to 0. So the first question was answered and it was answered wrong. So probability of getting a wrong answer is Q. The second question was answered and again it was answered wrong. So again the probability is going to be Q. The third question answered also wrong and the fourth also answered wrong. So probability is Q raised to 4. You can later on put the values also. So at the beginning we are going to generalize it. So first time it was answered wrong, second time also, third time also, fourth time also, every single time the question was answered wrongly. Hence the probability of getting a wrong answer is Q raised to 4. Getting all the questions as wrong answer is Q raised to 4. The next I can discuss is when P, or I can say first of all x is equal to 1 question is answered correctly. Now when I say 1 question is answered correctly, this point should pop up in your mind. When I say 1 question is answered correctly, which question is answered correctly? You are attempting 4 questions. There is question number 1, question number 2, question number 3, question number 4. Out of the 4 questions, only 1 question was correct. So you should ask a question, which question came correct? So there is a possibility that the first question was correct and the next 3 were wrong. There is a possibility that the first question is wrong, second is correct and the next 2 questions are wrong. There is a possibility that the first 2 questions are wrong, third is correct and the fourth question is wrong, and there is again a possibility that the first 3 questions are wrong and the fourth question is correct. So have you understood what I said just now? If I am going to say that only 1 question came correct, so you should immediately start thinking which question came correct. There is a possibility that the first question might be correct and the next 3 are wrong. There is a possibility that the second question is correct and the other 3 are wrong. There is a possibility that the third question is correct, the fourth question is correct and so on. So if I want to write for probability of x equal to 1, so probability of x equal to 1, how should I be writing? Observe carefully. Probability of x equal to 1. There are 4 different possibilities I have discussed. The first question was answered correctly. What is the probability of getting a correct answer? It is P. The second question was answered wrong. The third also wrong. And the fourth also wrong. So P into Q into Q into Q. This is one of the possibilities. This is the possibility when your first question was correct. But there is another possibility when the second question can come correct. So if the second question was correct, that means the first question was wrong. So the first question was wrongly answered. The second question was correctly answered. The third and the fourth questions were wrongly answered. So into Q into Q. Again, there is another possibility. You can answer the third question correctly. So when the third question is answered correctly, the first 2 are answered wrong. So probability of getting wrong answer was Q. So Q and second question also Q. The third was answered correctly, so P, and the fourth was answered wrong, so again Q. And finally, the last possibility is where the first three questions are answered wrong and the last question was answered correctly. So these are the four different possibilities in which you can have one question answered correctly. So every time I will get the probability of getting one correct answer as P into QQ. Everywhere I will get the same answer, P into QQ. That means this can be written as 4 times of P into QQ. So that's the probability of getting one correct answer. Now let's move on to the next case when x is equal to 2. That means out of the 4 questions you have answered 2 correctly. So 2 questions are answered correctly. So when I say 2 questions are answered correctly, again the question should come to your mind. You should start thinking about this one concept. If 2 questions are answered correctly, which 2 questions are answered correctly? Is it possible, so I'm going to write the probability directly. Is it possible that the first 2 questions are answered correctly? So P and P, and the next 2 questions were answered wrongly. So into Q into Q. That's one of the possibility. Let's think about some other possibility. Is it possible that the first question was correct, the second was wrong, the third was wrong, and the fourth was correct? So P, Q, Q, and P. Then again, the next possibility is P, Q, P, Q. First is correct, second is wrong, again third is correct, fourth is wrong. The next condition could be now Q, Q, P, P, isn't it? The first 2 questions are answered wrongly and the next question was answered correctly. And the last, okay, 1, 2, 3, 4, okay, there are 2 more left. So next one I can discuss. The first question was answered correctly, the second was wrong, the third is correct, and the fourth is wrong. That's one of the possibility. And the last possibility that I can discuss is Q, P, P, Q. Now, getting the values like this is a bit confusing. You will never be able to get the answers the way that I've got. Now, what is the best way of understanding this concept? How to write these things? It is very simple. I can say how many questions I want to attempt. I want to attempt 4 questions. Out of the 4 questions, how many questions came correct? 2 questions came correct. So I can simply write 4C2. So 4 questions were answered and out of the 4 questions, 2 questions came correct. So how many different possibilities can be there? So it can be obtained by 4C2. So this is the concept that we have learned in our lower standards in permutation and combination. So 4C2 if you solve, it is going to become 6. I hope that you already know the formula of NCR. NCR, it is n factorial upon r factorial into n minus r factorial. Make use of it and get the answer of 4C2 as 6. That is why 6 different possibilities has to come. So if you observe everywhere, the answer is going to be P square Q square. So everywhere P square Q square is going to come. That means the probability of getting 2 correct answers is 6 times of P square Q square. Finally, I will talk. Okay, there is one more left. So I'll first of all talk about x equal to 3. So probability of x equal to 3, that means 3 questions are answered correctly. So I'm going to write it directly now. When 3 questions are answered correctly, the first possibility is going to be all first 3 are correct, the last one is wrong. The next one would be PP, QP. The next one would be PQ, PP. And the last one would be Q, P, P and P. So the last question was wrong, the third question was wrong, the second question was wrong, the first question was wrong. So when one question is wrong, these are the 4 different possibilities. So again, if you observe, every single time the answer is going to come PQ, Q. So PQ, Q, and it came 4 times. So that's 4 PQ, Q. And finally, if I talk for x equal to 4, that means all the 4 questions are answered correctly. So I started from 0 question. That means 0 success. Your success is 0. Then I said 1 success, then 2 success, then 3 success. And finally, I'm going to talk about 4 success. 4 success, that means all 4 questions were answered correctly. So probability of x equal to 4. First question answered correctly, probability is P. Second also answered correctly, again P. Third also P. Fourth also P. So the answer came P raised to 4. Now if you observe, these 5 different possibilities that I have discussed, if I try to accommodate them in a table, so the table would look like this. There is x and there is the probabilities of x equal to xi. So when x was 0, that means I had 0 success. So for 0 success, my probability came q raised to 4. So I'm going to write here q raised to 4. Then 1. That means when there was 1 success, I was able to answer only one question correctly. So at that time, my probability came 4pqq. So I write 4pqq. Then 2. For 2 success, I have 6p square q square. That's my probability, 6p square q square. Then for 3, that means 3 questions were answered correctly. My success is 3. The answer came 4pq. Q, 4pq, q. And when all the 4 questions were answered correctly, it is going to become p raised to 4. Construction of this table is called as distribution of the probability. The condition has been distributed into 1, 2, 3, 4 and 5 possibilities. Again, if you observe the values that I have got here, observe these values that I have got here. If I try to take the sum of them, let us take the summation of all the probabilities. So it is going to be p of x equal to xi, it is going to be q raised to 4 plus 4p qq plus 6p square q square plus 4pqq plus p raised to 4. I hope you must be recalling the binomial expansion. If you observe the binomial expansion of a plus b raised to 4, the binomial expansion of a plus b raised to 4, look at the shortcut technique of getting the binomial expansion, a plus b raised to 4. The first term is a, so I write a raised to 4. Then I write a cube, then I write a square, then I write a, and finally I write a raised to 0. A raised to 0 is going to become 1. Second term is b, so I begin from b raised to 0, then I write b, then I write b square, I write b cube, I write b raised to 4. Then from the Pascal's triangle, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You must be recalling these shortcut techniques. So the Pascal triangle for power of 4 is 1, 4, 6, 4, 1. So I can simply put 1, 4, 6, 4 and 1. So put up a plus sign in between. So a raised to 4 plus 4 times of a cube b plus 6a square b square plus 4ab cube plus b raised to 4. So if you observe this and this, they are exactly same. See, a raised to 4, you have q raised to 4. Then a cube, a square, a. So q cube, q square, cube and q raised to 0. Then p raised to 0, p raised to 1, p raised to 2, p raised to 3, p raised to 4. So this is nothing but binomial expansion. So it's going to become q plus p 4 to the power 4. And we already knew that p plus q is going to be 1. P plus q, so 1 by 4 and 3 by 4, it gave us 1. So this is going to be 1 raised to 4, or I can simply write 1. That means sum of all the probabilities is also coming 1. That means it is definitely a distribution. So this distribution is called as binomial distribution because it represented the binomial expansion formula. That is why the distribution is also called as binomial distribution. But it was invented by Bernoulli's, hence it is also called as Bernoulli's distribution. So I'm going to create a formula for this one now. So this is what the binomial distribution will look like. We have taken an example. Exactly same examples you can have in different questions. You will always have only 2 outcomes. So whenever there are only 2 outcomes, the question is definitely on binomial distribution. All the problems can be solved by Poisson's as well as normal distribution, but we will look into those 2 concepts in our next lectures. So I am going to construct one basic formula for binomial distribution, getting probabilities of binomial distribution. So the probability formula goes something like this. So P of x equal to xi. Xi is your success. P of x equal to xi, when I say xi, the value becomes your success. Success cannot be what you can say decimal numbers. It has to be always integral numbers, and that too only positive integral numbers. So I can say success is 0, success is 1, success is 2, 3, 4, 5, 6 and so on. It cannot be 1.5 or 2.7 or 3.4. So success is always either 0, 1, 2, 3, 4 and so on. That is why binomial distribution is applicable only and only for discrete random variable. So I will write the formula P of x equal to xi. The formula goes like this. All these things that I have evaluated, they were considered only for a small example. I have taken only 4 4 trials over here. I have discussed this question only for 4 trials for better understanding. I can expand this concept for 10 number of trials, 15 number of trials, 100 number of trials, but then it becomes too difficult for us to manage this much data. Hence we are going to devise a formula. The formula can be definitely obtained from here itself. So I'm going to write the formula and then I'm going to cross check it with the values that I've got. The formula for binomial distribution goes like this. Try to memorize it. NCX. You already know what is N. N is the number of trials we have seen. Here you are attempting one question, then the second question, then the third, and then the fourth. That means you are doing one particular activity 4 number of times. That becomes your trial. So N was 4 in our case. X is your success. X was taken as 0, then 1, then 2, then 3, then 4, and so on. Since our question had only 4 trials, we can have success only up to 4. So that there was X ka value as 0, then it was 1, then 2, then 3, then 4. So X is number of success into P raised to X. P stands for the probability of success. X, as you already know, it is number of success. And Q raised to N minus X. That's your formula for binomial distribution. Now let's cross check this formula. Is the formula correct or not? So over here, if you observe, here the number of success was 0. The number of success is 0. So X is 0. So I'm going to put X as 0 here. So I put X as 0 here. Then number of trials is 4. So I'll write 4 here. 4. N is 4. 4C 0. I hope you all know the basic concepts of permutation and combination. N C 0, the answer is 1. So N was 4, number of trials was 4, and success was 0. So it becomes 4C 0. 4C 0 gives me 1. P is the probability of success. So let's write P only. Success is 0. So P raised to 0. Again it becomes 1. Q raised to N minus X. Number of trials was 4. Success was 0. That's why I write Q raised to 4. So that's my probability. See, Q raised to 4. Similarly, if I take one success, I'll put X as 1. I'll put N as 4. So 4C1. I hope you know that 4C1 is nothing but 4. So I write 4 here. P is the probability of success. Success is 1. So P raised to 1. N is number of trials. It was 4. X is success, which was taken as 1. So 4 minus 1, that becomes 3. So Q. So it is 4C1, that is 1. Then that is 4, sorry, 4C1, that is 4. P raised to 1, that is P. Q raised to 4 minus 1, that is 3. Q. 4P, and so on. You can get every single value from here using this particular formula. So whenever you want to solve any question in which there is binomial distribution, either it will be directly mentioned in the question, or you have to identify based on the number of trials and the outcomes of the trials. Whenever there are only 2 outcomes possible for a given trial, the problem definitely can be solved by using the binomial distribution. So the formula for binomial distribution, one last time, it is NCX, P raised to X, Q raised to N minus X, where N is number of trials, X is the number of success, P is the probability of success, Q is the probability of failure. So that is how we can understand binomial distribution. In my next video, I will be discussing few questions on binomial distribution. Make sure you keep on watching. Thank you so much.